Right, good afternoon. So today we're going to be looking at linear equations in all three forms. We've talked about slope-intercept form. We looked at point slope on Monday. Yesterday we looked at standard form. We're going to look at kind of all three of those today. So before we get started, let's kind of look at a review. If I have slope-intercept form, so that y equals mx plus b. Remember that this b is my y-intercept, and this m represents my slope. So in this problem, I have my y-intercept of 2. So if I'm looking to graph that, we can start at 2. And my slope is 3/4. So remember, we're talking about change in y, change in x. Since it is positive, I'm going to be moving up 3 units and to the right 4. So starting at that 2, I'm going to come up 1, 2, 3, and over 1, 2, 3, 4. You can add in more points if you want, or we can go ahead and draw in our line. Looking at number 2, we're looking for a graph that has a slope of -1/2. Being that is a negative, that means my line is going to be going downward. So we can automatically get rid of A and C. So we're looking for something that's going to go down 1 to the right 2. If I start at that y-intercept, I'm coming down 1 to the right 2 here at B. And just to check, I want to come down 1 to the right 2 for D, and that doesn't match. So B is going to be our answer. Okay, let's go ahead and jump into our lesson for today. So today there are 3 major forms of linear equations. These equations give enough information about the lines so that we can easily graph them. You can switch between different forms. Okay, so our linear equations, the most common one we use is that slope-intercept form, which is y equals mx plus b. But we've also talked about point slope, where we have y minus y1 equals my m, or my slope, times x minus x1. Then the one we talked about yesterday is standard form, where we have ax plus by equals c. All right, so let's look at example 1. Example 1 says, write an equation in point slope form for the line that best passes through 6, 3 with a slope of 5. So I did give you the table to kind of break down the information. So the info given, we are given a point, which in this case is 6, 3, and we're given slope, which was 5. So the next column, it's asking for my slope. It gave us the formula. However, it gave it to us. So we're just going to write that m equals 5. The next part here, we're looking for point slope. So we're just plugging in that 6 and that 3 into this equation. So think about if I have 6, 3, I'm putting in 6 for my x value, 3 for this y value. So we're saying y minus 3 equals my slope of 5 times x minus my x value of 6. And that is it for my point slope. However, the new part in the next part is turning it into slope-intercept form. So I'm going to rewrite my problem. And you should be writing this down as well. Remember, we talked about distributive property a little bit earlier in the year. Anything that I have on the outside, I want to multiply to everything inside. So I'm going to go ahead and bring my y minus 3 down. 5 times my x, or my unknown, is just going to be 5x. And 5 times negative 6 is negative 30. So here we see that we are extremely close to finding that slope-intercept form. I just need to get rid of this minus 3 so that y is by itself. To get rid of it, the opposite is going to be adding 3 to both sides. When I do that, my 3's zero out, giving me y on the left side. There's nothing with my 5x. I'm going to bring it straight down. And negative 30 plus 3. Remember, you can use your Desmos calculator, but you are going to get a negative 27. So there's our final answer for slope-intercept form. You make sure that you are filling in each piece of the table with given information, my slope, whether you have to work it out or not, point slope in our slope-intercept form. You're going to go ahead and work out example 2, 3 on your own. But hop to that second page where we're talking about standard form. Standard form, yesterday we talked about that equation being the ax plus by equals c. Some requirements to remember is that a is only a whole number. And that b and c are integers, meaning they are positive or negative whole numbers. No fractions, no decimals, any of that. So here's example 4. Write the equation in standard form for the line that passes through 3, negative 2 with a slope of negative 3. So similar to example 1, we are given a point. In this case, that point is 3, negative 2. And we're given slope of negative 3. So that second column, we're asking for slope. It gave it to us already. We're just going to write in m equals negative 3. And then plug in that point slope information. So in this case, we had 3, negative 2. I want that x value to come in for x, y value for y. So if I say y minus my y value of negative 2, my slope was negative 3 times x minus the x value of 3. Hopefully we've already noticed this double negative. So I can't have double negatives. I'm getting that positive. So to simplify our problem, I'm saying y plus 2 equals negative 3x minus 3. For slope-intercept, I'm going to rewrite my point slope form. I'm going to go ahead and simplify by distributive property. I'm going to do negative 3 times x, negative 3 times 3. So y plus 2 equals negative 3 times my variable of x gives me negative 3x. Negative 3 times negative 3 gives me a positive 9. We are almost to where we need to be with y by itself. I need to get rid of this plus 2. So the opposite, I need to subtract 2 from both sides. Positive 2 minus 2 is 0. leaving me just my y. Nothing is happening with my -3 in my variable. Bring it down. But I have 9 minus 2, which gives me a positive 7. So now I have my slope-intercept form. Y equals -3x plus 7. Okay, so our last part, standard form. I want to start with my slope-intercept. So we had y equals -3x plus 7. I want to get my ax and by, meaning both my x and y values, to the left-hand side. So we're kind of doing a little bit opposite of what we just did. So to get this minus 3x to our other side, I need to do the opposite. And in this case, add 3x to both sides of that equal sign. So we keep my positive 3x plus y equals 7, since my -3 and positive 3 cancel out. Down at the bottom, we're looking for, is it a positive ax? It sure is. Are there any fractions or decimal? There is sure not. If you have a negative number, just remember that you can simply divide every piece by that negative number to change that out. Okay. So here, example 5 through the end, you're looking at giving that information that it gave us all the way to standard form and filling in each section of the table. When you finish, make sure that you are turning it in. You will turn it in at the end of class, no matter what. And if we need to, we will pick it back up on Thursday when we return. Okay.